We're talking about blind women seeing flashes 150 miles away, radioactive green glass that's now a collector's item, and scientists who went from celebration to existential horror in seconds. They nicknamed the most destructive weapon ever created the gadget, like it was a science fair project. But before we get to the world's most terrifying science experiment in the New Mexico desert, we need to understand how this whole nightmare started. And it begins with a letter that Albert Einstein never wanted to write. Meet Leo Szilard. He's a Hungarian refugee physicist who, in 1939, realized something terrifying. Germany had just stopped exporting uranium from occupied Czechoslovakia. Now, why would they do that? Szilard knew exactly why. He understood the implications of nuclear fission immediately. With Nazi Germany's scientific capabilities and their access to uranium, the pieces were falling into place for Hitler to potentially get an atomic bomb first. Which is crazy, but here's the twist though. Einstein didn't invent the atomic bomb concept, he was basically recruited as a famous spokesperson. On August 2nd, 1939, Einstein signed a letter primarily authored by Leo Szilard to President Franklin Roosevelt. Think about the irony here. Einstein, a lifelong pacifist who fled Nazi Germany, warning the American president about weapons of mass destruction. The letter said Germany might develop nuclear weapons and the United States needed to act immediately. It prompted initial government funding for uranium research, though not the full-scale Manhattan Project yet. This wasn't a light decision for Einstein. He later called signing that letter one of his greatest regrets. Roosevelt took it seriously, but moved slowly at first. Initial funding came in 1939, with increased activity through 1940 to 1941. The Manhattan Project was formally authorized by President Roosevelt in January 1942 and placed under Army Corps of Engineers control, transitioning from smaller research efforts to a massive industrial program. During that time, scientists feared Germany was racing ahead, getting closer to the bomb every day. The clock was ticking. Everyone knew that whoever got there first might win the war, or worse, end the world. But here's the thing about building an atomic bomb. Before you can create a weapon, you need to prove the science actually works. You need to show that you can sustain a nuclear chain reaction. And that's where things get really interesting, because they decided to do it under a football stadium. At December 2nd, 1942, under the west stands of Stagg Field, the University of Chicago's abandoned football stadium. Try to wrap your head around this. They were building humanity's first nuclear reactor under the bleachers where fans once cheered for touchdowns. The project was led by Enrico Fermi, an Italian refugee physicist who'd won the Nobel Prize. His team was constructing something called Chicago Pile 1, which was literally a stack of graphite bricks and uranium arranged in a precise geometric pile. Achieved the first self-sustaining nuclear chain reaction. This was theoretical physics becoming terrifyingly real, and they were doing it under a sports stadium. Here's how it went down. Fermi's team slowly withdrew control rods from the pile while monitoring neutron counters. Each inch they pulled the rods out, neutron levels climbed higher. The tension must have been unbearable. Then, at 3:25 p.m., the pile went critical. Neutrons were multiplying on their own, sustaining the reaction without external help. Fermi, characteristically calm, announced the pile has gone critical and ordered it shut down after 28 minutes. Eugene Wigner, another physicist, had brought a bottle of Chianti to celebrate. They drank from paper cups in complete silence. They'd just proven controlled nuclear fission worked. Pandora's box was officially open. Someone later said, "This will go down as a black day in the history of mankind." But they proceeded anyway. This moment was huge, because it proved you could sustain a chain reaction. Here's the fundamental challenge. You need a critical mass of fissile material to go supercritical really fast. Normally, too many neutrons just escape into the air before they can split other atoms. You need extreme density and extreme speed. Scientists had two materials to work with. Uranium-235, which is incredibly rare and hard to separate from regular uranium-238, and plutonium-239. Literally doesn't exist in nature and has to be manufactured in nuclear reactors. Two different materials, and they came up with two completely different design approaches, the gun type and the implosion. Nobody had ever done this before. It was all theoretical, with billions of 1940s dollars at stake. The gun type design was beautifully simple. You take one piece of uranium and literally fire it into another piece, like shooting a bullet into a target. When they combine, boom, you've got a supercritical mass. They called it Little Boy, and here's the crazy part. They were so confident in this design that they never tested it before dropping it on Hiroshima, just used it straight on a city. Why would it work for uranium? Because uranium-235 has low spontaneous fission rates, so the relatively slow gun assembly, which takes milliseconds, worked just fine. No premature detonation. Think about that for a second. They dropped an untested weapon on a city with hundreds of thousands of people based on purely theoretical calculations. Would you have that kind of confidence in your math? Drop a comment if you think that was justified or absolutely insane. Well, the implosion design? That's where things get insane. You take a sphere of plutonium and compress it using precisely synchronized explosives all around it. 32 detonators firing simultaneously, with shaped explosive lenses creating a perfect spherical shockwave that crushes inward. The goal is to compress the plutonium to twice its normal density in just microseconds. Components included a plutonium core, uranium tampered to reflect neutrons back in, explosive lenses made from different explosives like composition B and barytol, and a polonium-beryllium initiator to release neutrons at exactly the right moment. The timing requirement? Nanosecond precision across all 32 detonation points. Miss by even a few microseconds and you get a fizzle instead of an explosion. They called this design Fat Man because of its bulbous shape. All of this was happening at Los Alamos Laboratory in remote New Mexico. Established in 1943, J. Robert Oppenheimer was coordinating thousands of scientists, including Hans Bethe on theory, Enrico Fermi, Richard Feynman, and many European refugee physicists who'd fled the Nazis. The pressure was immense. They were racing against fears of German progress, working 80-hour weeks, designing a weapon based on calculations that had never been tested at full scale. Everything was theoretical, and they thought they had it figured out, both designs ready to go. Then plutonium decided to ruin everything. Spring 1944. Everything seemed on track. Los Alamos had planned to use the simple gun-type design for both uranium and plutonium bombs to weapons. Same basic mechanism. Should be straightforward, right? Then they made a discovery that caused absolute panic. Reactor-bred plutonium wasn't pure plutonium-239. It contained the plutonium-240 isotope mixed in, and plutonium-240 has extremely high spontaneous fission rates. What does that mean? It randomly emits neutrons. So if you tried to use the slow gun-type assembly, those spontaneous neutrons would cause the bomb to pre-detonate before it was fully assembled. You'd get a fizzle, basically an expensive dud. Imagine spending billions of dollars and years of work only to discover your main design is completely unusable. The gun-type timing was just too slow for plutonium. Taking milliseconds to assemble meant the spontaneous neutrons from plutonium-240 would almost certainly trigger a premature chain reaction. The math was brutal. Pre-detonation probability approached 100%. Here's the nightmare scenario. Hanford's massive reactors were producing plutonium, not uranium. Billions of dollars invested in plutonium production. Scientists described this as a crisis that threatened the entire plutonium program. There was only one solution: perfect the insanely complex implosion design. Make it so fast, compressing in microseconds, that even spontaneous neutrons wouldn't matter. This realization came in 1944. They had maybe a year to solve it, or the plutonium program was dead. Los Alamos went all in on implosion. It became the absolute priority. Those explosive lenses that had been failing repeatedly in tests, they had to work now. There was no backup plan. More scientists assigned, more explosive tests in the desert, round-the-clock work. General Leslie Groves, the military head of the Manhattan Project, was furious about the wasted plutonium production effort, but there was no choice. They'd come too far to quit. The only path forward was to do the impossible: create a perfectly symmetrical implosion using chemical explosives with precision never before achieved. Which brings us to the part where these brilliant theoretical physicists started blowing things up in the New Mexico desert over and over again, trying to get it right. As the Trinity test approached in July 1945, the scientists at Los Alamos were nervous wrecks. Years of work coming down to done moment. So how would they cope? They started a betting pool on the explosive yield. Seriously. Guesses ranged from 0 kiloton, meaning a complete dud, to atmospheric ignition, literally destroying the world. Imagine betting on whether your science project destroys civilization. Oppenheimer, the scientific director, estimated the yield would be between 0.3 and 4 kiloton, though the actual yield of 19 to 22 kiloton exceeded even his upper estimate. Edward Teller, always the optimist, bet wildly high. The absurdity of this betting pool perfectly captures the surreal nature of what they were doing. These scientists were real people dealing with impossible pressure, and it shows in the quirky ways they handled it. Richard Feynman became famous for picking locks at Los Alamos for fun, discovering classified documents left in supposedly secure safes. These weren't emotionless robots. They were terrified people using humor as a shield. The test was originally hoped to occur around early July 1945, with July 4th mentioned as a symbolic target date, though technical issues made this unrealistic. The actual scheduled date became July 16th, 1945. They built this massive thing called Jumbo, a 214-ton steel containment vessel, designed to recover the plutonium if the test failed. It never got used, became obsolete, and just awkwardly survived the blast nearby. General Groves initially opposed testing at all because he didn't want to waste the expensive plutonium. But Oppenheimer convinced him they had to know if it worked. After years of work, billions of dollars, and countless failures in explosive lens tests, everything came down to one moment in the desert. And that moment almost didn't happen because of a thunderstorm. Jornada del Muerto Desert in New Mexico. The name literally means Journey of the Dead Man. July 16, 1945. The test was scheduled for 4 a.m. The gadget sat, suspended from a 100-foot steel tower, this bulbous sphere of explosives with a plutonium core at its heart. Scientists were positioned in bunkers over 5 miles away. Some wore welding goggles for eye protection. Others just planned to turn away. The atmosphere was dead silent, except for the wind. Years of work, all hanging on this moment. The scheduled 4 a.m. detonation time came and went. They couldn't fire. A thunderstorm had rolled in. Oppenheimer was described as a nervous wreck, chain-smoking, pacing. General Groves anxiously checked weather reports every few minutes. The pressure was crushing. They couldn't delay too long because President Truman was at the Potsdam Conference with Stalin and Churchill, and he needed to know if this weapon actually worked. It would fundamentally change the negotiations. 5:20 a.m., the weather cleared just enough. New detonation time, 5:29 a.m., Mountain War time. Some sources say 5:29:45 precisely. The final 10-second countdown felt like an eternity. Everyone was holding their breath. Then it happened. 5:29 a.m. The world changed. Flash was brighter than 1,000 suns, visible 150 miles away in every direction. The color progression was incredible. Blinding white, shifting to yellow, then red, then purple as the fireball rose. Observers over 5 miles away felt intense warmth on their exposed skin, like standing too close to a bonfire. The shockwave knocked people down at the observation bunkers, rattled windows over 100 miles away. The 100-foot steel tower completely vaporized. It just ceased to exist, as if it had never been there. Desert sand underneath melted at temperatures over 1,700 degrees Celsius, forming radioactive green glass they called Trinitite. Across a wide radius, the mushroom cloud rose 7.5 miles high, expanding and churning. The yield was 19 to 22 kiloton, far exceeding most predictions. Remember, Oppenheimer guessed 0.3 to 4 kiloton. They'd unleashed something beyond their expectations. Reactions were immediate and stunning. Georgia Green, a blind woman 150 miles away, reported seeing the light. Impossible, but true. Some observers saw the bones in their hands through their closed eyelids from the intense flash, like an X-ray. After the blast, there was stunned silence before anyone could speak. Kenneth Bainbridge, the test director, turned to Oppenheimer and said bluntly, "Now we are all sons of bitches." No poetry, just profane honesty about what they'd done. Oppenheimer's mind went to the Bhagavad Gita, the ancient Hindu scripture. Now I am become death, the destroyer of worlds. The mood at the laboratory was described as euphoria mixed with sobriety. technical triumph shadowed by moral dread. Some people celebrated, others stood in complete silence, processing what they'd just witnessed. Here's the science. Trinity released 19 to 22 kiloton of energy. That's the equivalent of 19,000 to 22,000 tons of TNT, exploding in microseconds. The light wasn't just visible spectrum. It included X-rays and gamma rays. For Georgia Green, the most likely explanation is that the intense electromagnetic radiation stimulated her retinas directly, or she had partial light perception that responded to the overwhelming brightness. At ground zero, temperatures exceeded the surface of the sun. The weight of what they'd created was immediate and crushing. He later called the moment one of profound moral reckoning. This was a man who'd driven the project forward with brilliant intensity, coordinating thousands of scientists, solving impossible problems. And now, watching that fireball rise into the sky, he understood what he'd actually done. The transformation in Oppenheimer was stark. Before Trinity, he was a brilliant, confident theoretical physicist pushing the project forward at all costs. After Trinity, he became increasingly tortured by the implications. His mood darkened visibly. No test for Little Boy. The gun-type design was mechanically straightforward. Fired chunk of uranium into another chunk. Low failure risk because uranium-235's low spontaneous fission rate meant premature detonation was nearly impossible. But here's the real reason: material scarcity. It took years to enrich enough uranium-235 for even one bomb. The enrichment process at Oak Ridge was incredibly slow and expensive. General Groves made the decision that they couldn't justify wasting half their entire uranium supply on a test when they were confident it would work. The contrast is stark. Implosion was complex enough, with all those explosive lenses and precise timing, that Trinity was absolutely necessary to validate it. But the gun, they take hundreds of thousands of lives on untested calculations. August 6th, 1945, 8:15 a.m. local time in Hiroshima. Little Boy detonated with a yield around 15 kiloton, slightly less than Trinity. Killed 70,000 to 80,000 people. Immediately, by the end of the year, over 140,000 were dead from the blast, burns, and radiation. August 9th, Fat Man, the tested implosion design, destroyed Nagasaki. The combined death toll exceeded 200,000 people, mostly civilians. Japan surrendered on August 15th, ending World War II. Little Boy worked perfectly. The calculations were exactly right. Immediately after the war, Oppenheimer became a national hero, celebrated as the father of the atomic bomb. But his response to that fame was complicated. He became increasingly vocal about nuclear arms control and international oversight of atomic weapons. He argued strongly against developing the hydrogen bomb, which would be far more powerful than the fission bombs they'd created. His reasoning? He feared an unbounded nuclear arms race with the Soviet Union that could end human civilization. Teller and other scientists pushed hard for the H-bomb. A divide opened up. Oppenheimer's moral stance on one side, military hawks' strategic arguments on the other. Oppenheimer had become inconvenient. 1954, 9 years after Trinity, Oppenheimer faced a security hearing that destroyed him. The accusation? He was a security risk due to past left-wing associations and his opposition to the hydrogen bomb. This was peak McCarthy-era anti-communist paranoia. The hearing was humiliating. They investigated his loyalty, scrutinized his past friendships, questioned his judgment. His past came back to haunt him. He'd briefly associated with communist groups in the 1930s before the war, when lots of intellectuals flirted with leftist politics. Former colleagues testified against him. In December 1954, his security clearance was revoked. Professionally destroyed. Reputation shattered. The government destroyed Oppenheimer's career because he developed a conscience about the weapon he created. Was punishing him for advocating nuclear restraint justified, or was it one of America's greatest injustices? Let me know what you think. President Kennedy approved the Enrico Fermi Award for Oppenheimer in 1963, but President Lyndon B. Johnson presented it after Kennedy's assassination in December 1963, a kind of rehabilitation. But it was too late. The damage was done, his influence permanently diminished. He'd become a cautionary tale about what happens when scientists develop consciences about their creations. The lesson from Oppenheimer's story is brutal. Even creators can't control what they create. Pattern repeated across the Manhattan Project. Many scientists became anti-nuclear activists, haunted by what they'd built. Leo Szilard, the man who convinced Einstein to write that original letter to Roosevelt, later petitioned against using the bombs on Japan. The man who started it all tried to stop it at the end. The guilt haunted these people for decades. Some never forgave themselves. Modern historical assessment sees Oppenheimer as tragically prescient about nuclear dangers. He was right to fear the arms race. He was right to advocate for control. And he was punished for being right. But Trinity's legacy goes far beyond one man's personal tragedy. It changed the entire world forever. The Soviet Union's response to Trinity and Hiroshima was swift. The Soviet Union detonated their first atomic bomb on August 29, 1949, only 4 years after Trinity, much sooner than US intelligence expected, largely due to intelligence gathered by spies like Klaus Fuchs. The nuclear arms race was on. The United Kingdom tested in 1952, France in 1960, China in 1964. More nations followed. Then came the hydrogen bomb. First tested in 1952, roughly 1,000 times more powerful than the Trinity device. At the height of the Cold War in the 1980s, there were over 70,000 nuclear warheads worldwide. Today, there are still around 13,000. Trinity opened Pandora's box, and it can never be closed. That's the legacy. Trinity site itself is now part of White Sands Missile Range in New Mexico. The public can only visit twice a year, in April and October, for just a few hours each time. The radiation is still measurable, though it's considered safe for brief visits. The crater is still there, 5 feet deep, 30 feet wide, a permanent scar on the desert. Trinitite, that radioactive green glass, is illegal to remove now, but collectors prize pieces that were taken before the ban. Nuclear scientists and history buffs make pilgrimages there annually. There's a simple stone obelisk marking Ground Zero. It's remarkably understated for such a momentous location. Standing there, you can still feel the weight of what happened. Modern nuclear weapons have evolved dramatically from Trinity's crude gadget. They use fusion boosting, two-stage thermonuclear designs, sophisticated explosive lens geometries. They've been miniaturized. Warheads now fit in suitcases where Trinity's device needed a 100-foot tower. Computer-designed implosion systems are tested through simulation rather than live tests. The power has increased to megaton-range weapons that dwarf Trinity's 20-kiloton. Advanced arming and safety systems prevent accidents. 9 nations now possess nuclear weapons. The threat isn't just nations anymore. There's serious concern about terrorist groups acquiring nuclear materials or weapons. The technology has spread far beyond what those scientists in 1945 could have imagined. 78 years later, we're still living with the consequences of what happened at 5:29 a.m. in that New Mexico desert. Humanity created the power to destroy itself in microseconds. We've had 13,000 nuclear warheads pointed at each other, and somehow we're still here. Either incredibly lucky or incredibly wise, depending on who you ask. Trinity wasn't just the first bomb test. It was the moment we gained godlike power without godlike wisdom. Oppenheimer's haunted quote still echoes, "Now I am become death, the destroyer of worlds." So here's the real question. Was Trinity humanity's greatest achievement or our greatest mistake? Drop your answer below, and if you want more stories about the moments that changed everything, subscribe. History's full of them.